of detergents, acids, and the products that we use and how that we use them. So for those of you that have been doing this for years, there'll be some stuff in here that's super basic. And for those of you that are just kind of learning your way through it, we'll start there for you. So basics on our products as well, a little bit of the lineup of items that we sell so that you get a better idea of what's available to you. With a lot of the prices changing and the things that we've been going through this year, you'll be able to see maybe some options that you haven't used in the past. So again, we're doing our CIP Chemical Solutions. So what are the steps to getting a good CIP cleaning? We definitely want to use the right tact or tactics here. So I've heard this said in a couple of different ways, from chat or tact. And in this case, we're talking about time, action, temperature, and chemical. So those are the things that we need to use to get a good results with what we're doing. It's not just chemicals. It's not just about the product. It's about all of these things put together. Takes that complete approach. One's lacking, we definitely need to use it. And using a pie chart's a good example for this. If we pull some of it out, it does have to be filled in with one of the other three that way. So time, when we're looking at a traditional wash system, pre-rinse till it's clean, and 8 to 10 minutes on detergent time. Again, this can vary by manufacturer and setup and system that you have, but these are some good basic guidelines. 3 to 5 minutes on the acid, 3 to 5 minutes on a sanitize cycle. As far as the action goes, we are definitely looking for good slugs. Slug being that column of water that gets pushed through rather than just filling the line, but actually pushing through with our air injection and such that way to be able to get a good solid slug of water. We want to make sure that we're getting at least that many in our wash to get enough action, keep things working well. Chemicals, of course, can vary by the chemical that you're using, but we want to make sure we're using proper concentration. Too much is not a good thing. Too little, of course, not a good thing. We can cause detriment by putting too much product in to either just having residual left over or causing damage to the system that's there. And then temperature, we want to think about this like the three little bears, as simple as that. It's got to be just right. We don't want it too hot or too cold. If we're using water that's too hot, we can actually be baking on some of our dirts and soils that we're trying to get off. We have seen that as a possibility and as an issue. So especially in that rinse cycle, when you've got things full of the fats and proteins that are in there with all the milk, we want to make sure we're in that rinse range temperature of 110 degrees, getting our system warmed up, helping to bring those temperatures to where they need to be when the weather's cold, but also at the right temperature to be pulling all of that out and getting a good clear rinse. Detergent temperature is a good rule of thumb, running 120 degrees for end temp. Doesn't necessarily matter so much as where you start. Once you start getting up into those very high temps, getting close to those boiling numbers, or even at 185, 190 plus, we can start and be looking in some instances of baking stuff on if you don't have a good clean line at that point. So the goal is that 120 degree end temp, keeping things in a good suspension before you start having those fats and proteins pulling out. And the acid, that can be based on what acid that you're using. We definitely hear of hot acid washes and such that way. And the hot acid wash stands for a couple of things with the hot. It's not only the hot temperature, but it's a hot amount of product, putting an additional amount of product in and doing a good strong wash at that point. So depending on the types of acid you're using, that temperature can vary. So while we're talking about the TACT, the temperature, action, chemical, and time here, just wanted to show a quick video. Just gonna play a little bit here. This is from the teaching parlor that Dr. Roger uses for his trainings and such that way, but this shows a good amount of action and how a slug should be looking in here. When we go ahead and get this started, you'll see on the initial action that's there. Let's move this. But you can see in this initial action, because this particular one is showing what that's definitely. So the steps of good CIP cleaning, we definitely want to make sure we're including all the right steps. So we've got pre-rinse, our caustic wash, which is our traditional detergents that we're using. Depending on the system, definitely in bulk tanks, but sometimes, depending on the way systems are set up, we will run an intermediate rinse, and then we'll run the final rinse or the acid rinse cycle. And then the sanitizing rinse being run either just before the milking starts again, or if it's an acid sanitize, it can be done ahead of time that way. But that intermediate rinse doing a good job of keeping things clean between a caustic wash and the acid rinse. This would be a good example of not using too much product. If you have too much detergent going in or you're overusing at that point and not getting a good clean in between, you could actually be leaving a good amount of your detergent in there and reducing the effectiveness or possibly even causing some mixing of the detergents and acids together. So if there's an opportunity for time for an intermediate rinse, that's definitely a good option. But in most of our cases, we don't see that in a parlor settings. And then showing on our website, this is one of the lines that we use. This is showing the other options that are out here as well, not just running a traditional rinse, detergent, acid, and sanitize, but also showing the options of saying, okay, we can run an acid sanitize cycle and eliminate a sanitize, or we can run a one-step and eliminate the acid cycle and then just do the sanitize if there's an opportunity for sanitizing. So the objectives of detergency. What are we looking to do when we're doing this cleaning, and what is the important aspect of it for the food safety? We're definitely looking for that. Ensure visual cleanliness of surfaces, looking for the disinfection step as well, preserving the shelf life of the equipment. So we want to make sure we're taking care of this, keeping the buildups off of it, not using so much that we're causing excessive pitting or rust or anything along that lines. And then also making sure that our food quality is kept in there as well. So we're using the right products so that we don't have any contamination, that there's no opportunity for changing flavors of milks or foods or such that way. So the solubility of the dirt, looking at a couple of different things here. What is in the organic deposits and what's in the mineral deposits. So basically you can see the lipids, the polysaccharides, the proteins you have from the milks, vegetable oil, sugars with the polysaccharides, and then of course protein would be the blood or milk on that as well. Those are all gone after by using an alkaline to take those out. Scale can be caused by the calcium carbonate. Scale comes from hard water and such that way, and the minerals that are in the water that we're dealing with. Salts, rust, all taken care of, being mineral deposits, better solubility with acid liquids with those. A little bit on the proteins. This gives a little overview of the isoelectric points can vary by pH value and by what we're looking at on each protein having its own specific point. So the alkaline pH has a negative protein charge, and by being that the opposite on the proteins that way, we're actually using solubility increasing with the alkaline pH. So that's, again, using the alkaline to go after the protein aspect. And mineral deposits, the acids solution, again, going after the mineral deposits are more soluble, and the higher temperature, again, based on the acids and the mineral deposits, may or may not work to help you in that aspect. Ingredients in each of our detergents. So this is by detergents, we're talking about the acid and alkaline based here. So we could have solvents, so whether it's a water, an ethanol, a glycerin, all something in there to be the solvent aspect of it. The pH regulators, these pH regulators being either acid based or the alkaline based, bringing the pH up or down from a standard average water pH level. We have the surfactants doing the work as well. I'll get into just a couple of information on the surfactants here in a moment, and then different additives that need to be added to it, or biocidal substances like chlorine, peroxide, those types of items as well. So surfactant, what is a surfactant doing in the water? What is it causing for a change here? So water has a property called surface tension. That surface tension is basically, if you think about the fact of when you wax your vehicle and you see that water beating up on a waxed vehicle, you have a nice bead that's allowing it to roll off. Or you have a well-worn metal surface in the same aspect, not waxed, not a good coat of paint on there or anything that way, and you will see that water droplet spread out more. This is the version of what you're seeing here. And with that surfactant, what it's allowing it to do is in some of those small pitted points that maybe we can't even see by eye, it's allowing that water to spread and to get a little bit more into those surface areas, giving us a little better cleaning in action that way by spreading that surface tension out across a wider area. The other aspect of it here is pulling the soils away. So you've got your soiled surface. And you have your surfactant surrounding the soil and basically helping to dissolve it and pull it away. You can see the way that surfactant just surrounds each of those little soil molecules, pulling it off and helping to separate it to give us a better clean. So CIP, we don't generally use foaming. It's more of a non-foaming aspect, but wanted to throw a little bit in here while we're talking about detergency on foaming. So where that role fits and what it's really doing. So just wanted to point out the foam doesn't have the detergency properties. Foam is a consequence of the surfactant properties. So that's using those surfactant side of things to help to pull that away. So the good quality foam is necessary to see that we've applied the cleaner. So in a surface cleaning aspect, this is where we'd be using that, and it allows a little better hang on for increased contact time as well. So nice strong foam reduces the detergency action and due to losing penetrating and covering properties. So having it too tight, too dry, we want to make sure we get a good balance of foam when you're doing these types of things to make sure you have that cross between the foam and the liquid form to get a good use of it in its cleaning and going after those, using those surfactants to aid in the detergency that way. So alkalinity in detergency, the objective of the alkalinity is hydrolyzing the fats and dissolving organic matters. And we want to make sure we have enough of a buildup and sufficient alkalinity with a reserve to maintain the pH despite when we're saponification of fats, carbonation, and neutralizing of any acids that are there. So want to make sure we have enough that we're keeping the pH at a good range, keeping the strength up. A couple of types of products that are used in alkalinity: sodium carbonate, sodium hydroxide, potassium hydroxide, and trisodium metasilicate. Our traditional detergents are using the sodium hydroxide, so our AgriClean products, we're using sodium hydroxide in this case, along with our surfactant package and conditioners packages in that. So water, we talk about detergency, we talk about the alkalinity and the acids and the different things we need to do, but how important is the water to this aspect of it? So water interacts with the organic and mineral dirts. That's what we're using, of course, is our action piece to pull all of this together and to carry the detergents to do the cleaning. So it's used as the diluting agent. It's used on the equipment and services and conditions of cleaning temperatures. So scaling is the biggest risk when it comes to water. So that, of course, is coming from our hard water situations and minerals and buildups that we have in there, but it can decrease the detergency capacity of any formula. So we want to make sure we're following what we've got in the water for hardness and what could be causing scaling in the midst of this. It combines with dirts, making their dissolution more difficult, and it can increase the risk of corrosion on surfaces because of that high temperature. So again, we want to make sure we're going after that scaling and keeping that to a minimum. And how do we remove the scaling when it comes right down to it? Little bit of information on the scale forming, the formulas that are here, and the alkaline and high temperatures. The reason we have this one in here is pointing out can increase the scale formation. We're pulling that from the water and causing more of an opportunity for those carbonate ions and hardness ions to be stuck and held onto the system that way. So, and solutions for removing scale is water softening, using of anti-scaling agents, and use of acids. So that's where a lot of times we're taking those minerals off with acids, but we can start that with water softening and go ahead and use that in a lot stronger situation of being able to keep that hard water at a lower level. So using the acidic detergents, just showing basically the breakdowns of different types of acids, the mineral acids and the organic acids. So descaling efficiency is measured according to the rate of dissolution of the calcium carbonate. Again, we use several different acids as we go through our products. We'll hit a little bit on what each of those has in them and finding the right acid for going after your best cleaning situation or the least detrimental to the equipment that you're using. So a breakdown here of the acids and what's the best properties of each of those. Anti-descaling properties, detergency capacities, the difficulties or problems that can come from them, as well as the advantages. Nitric, methylsulfonic, sulfamic, phosphoric, and sulfuric acid being the most common ones that are used, and showing each of these here. So you can see nitric definitely working as one of the best for the anti-scaling. Phosphoric does a little bit of a job there, sulfuric being the least. The inconveniences on each of these, the nitric, of course, can have some gassing and can be highly corrosive. So there are some systems that do not allow us to use any nitric on it that way, that we have to use some of the others and stick with ones and use a stronger amount of a phosphoric, something along that lines. Phosphoric, of course, we can have the phos left in the system. A lot of areas are trying to eliminate the effects of phos, so that can also be another one that we have to watch occasionally in that as well. And advantages. I mean, the advantage of the nitric is the oxidizing properties, advantage of the phosphoric, being less aggressive, strong detergencies, and doing well that way. Those being the two most common that are used in the dairy industry. We have the sulfuric acid that you see quite a bit as well. That is generally part of a mix and not always a super strong aspect of it. Sulfuric can also become a problem in a barium-rich area. So if you're fighting barium and having some that way, that will actually cause that to be left on the system a little bit more. So just a few details on each of the acids there. So corrosion, we see this a lot. A lot of times we can look at that and say, well, where do we see the most corrosion? Definitely in the milk house, where we have the water letting out and having the most gassing off, causing, excuse me, causing some of that. So corrosion's an alteration of the material by a chemical reaction with an oxidant. So we're seeing a lot of pitting in these systems. And where does that come from? So risk of corrosion is linked to all of these aspects: temperature, contact time, extreme pHs, chloride content, and oxidizing agents. So each one of these can have some effect to the corrosion. So again, keeping things in check with the right mix and right flare for what you're trying to accomplish becomes key in making our systems last as long as we can take care of them that way. And how do we avoid and take care of the corrosion? This is a slide from the food and beverage side of things, showing a little bit on the passivation of steel and then corrosion inhibitors. When a new system is put in, they're always running running the passivation on the steel, helping to remove any of this pitting and bringing a treatment to the system to help this keep from pitting and to last a far longer time. So shock treatment, best with the nitric acid, running that at 20% strength and at a temperature of 25 degrees Celsius for about 30 minutes. Will give you the passivization of the steel, and then you can run a preventative treatment as well to help to bring this stainless back to where it needs to be. So ingredients for detergents, again, we're back showing the alkalinity, acidity, surfactant, possibility of having some corrosion inhibitors in there as well, and any anti-scaling properties and complexing agents. So depending on which aspects and whether we're looking to remove proteins or looking to remove minerals, would be looking at each of the aspects. So you can see on this chart, again, alkalinities working best for the organic matters, and the acidity is working on the mineral side of things. Surfactants working well with the detergents as well, not as necessary with the acid side of it. So each of our products, getting into a little bit of details on our products, our AgriClean is our detergent product. So this is our alkaline CIP detergent. It's phosphate free, anti-foaming, working well in the CIP systems, using a polymer technology for superior emulsification, allowing us to use less alkalinity and chlorine in the mix. So that is working well in the corrosion aspect of helping us to keep corrosion down by not having to go as high. So rapid and clean sheeting of water off the equipment surfaces, ideal for a variety of water conditions. We have several different versions we'll show here on the next slide with what's available in that. So this is our key products of the line. There are many available. We have different strengths outside of these, but these are our key products that we're pushing and price list items that we have at the moment. Our AgriClean 305 and AgriClean 273, giving us our super strength, ultra duty chlorinated and our heavy duty chlorinated products. These are both working well for all types of hardnesses of water, designed to work up to 25 grains, possibly even higher than that, depending on strengths that way. Available in multiple sizes, as you can see there. The AgriClean 305 is designed to be used at a 1:3, 1:4 ratio. The AgriClean 273, again, at the 1:3 ratio. Both work very well. AgriClean 6010A and AgriClean AMS are both the non-chlorinated versions. These can be used with chlorine or with a peroxide-based product, depending on the countries you're in, whether they're allowing peroxide to be used in a system along this lines, but can be used with either. Even used in a lot of robot technologies and such without any chlorine in a system where chlorine is not allowed. This is a highly concentrated product and can be used at varying rates depending on the level of ppm and strength that you're looking for. So the AgriClean detergents are designed to work from a 600 ppm range and up. We see in a lot of traditional parlor systems that you are working well at keeping a good clean system at those levels and going up from there. And of course, depending on the amount of action that you have in the system and the amount of meters and turns and additional aspects of what you're going after, that can vary up in strength from there. We see it used up to a strength of in the 12 to 1500 ppm range. There isn't really a large need to go much above that in most traditional pipeline cleaning systems, and not having to get into a situation where you are causing additional corrosion or problems with the systems. So our acid line is called our Stronghold acid line. The acid rinse is used for dissolving mineral deposits, neutralizing the alkaline cleaners, and reacts with the milk minerals so they can be removed in that rinse cycle, helping to keep the equipment surfaces from hardened deposits, keeping biofilms away as well. And it's formulated to neutralize alkalinity and keep those buildups out of the system, and multiple variations of this as well. Because of the number of different acids that are used, there's a lot of variabilities, and a lot of them that are out there. This year with 2022 having seen some significant increases on traditional acids that we've used for a number of years, we are seeing a lot of changes of people using different variations of acids. Traditionally, our most popular acids have been our Stronghold 2510, 3505, and 4200. Those have been the staple of agrichem products, all the others still being available and used in different markets, but those 2510, 3505, and we have another one called 2010, which is our basic acid, all have a phosphoric and sulfuric blend. Phosphoric acid, of course, being one because of the fact it's not as strong and corrosive as a nitric acid, has been one that's been a constant use item. The cost, however, of the phosphoric acid is going up quite significantly, so we're seeing a rise in the use of some of the nitric blends with nitric and phosphoric, or nitric, phosphoric, and sulfuric. Those being the Stronghold NPS, the Stronghold NP50, and the Stronghold NP1000, giving a nitric, phosphoric, and sulfuric blend in different ranges and such that way. If that's something that you're not using, you can talk to one of your salespeople and work with them to pick your best product for use in your situation that way. The Stronghold 4200 and 7500 are both straight phos acids. So in a situation where you're trying to keep things as simple as possible and just using an acid that's going to give you some strong effect, but not a lot of in the corrosion aspect, those are both very strong versions of it and work well. We see the 7500 actually used in a lot of issues with sugaring, maple sugaring and such that way. That is used in the cleanup of that. So another aspect that could possibly be used for some of the chemicals that you do carry. And the Stronghold Citrifos is a citric and phosphoric blend. That one being an AMS line is used for robots in the detergent side, or I'm sorry, in the acid side of the wash and robots. The blend of citric and phosphoric is a one that's been used in Lely robots for a number of years. And we are seeing a lot of cases where those robots are now using just a phosphoric blend as well, with some added items in it to give some good cleaning aspect, with the robots running a one-step wash in each of their cycles of just an alkaline at one time and then an acid at the next time. So again, traditionally been a citric phosphoric based product, but we are seeing use of products like Stronghold 4200 as just a straight line item. So if you're looking for something that you can carry and use in multiple aspects, either one of those acids will work for both robots, Lely robots, as well as traditional parlor systems as well. So do have the Stronghold EnviroGreen. That one has an acetic acid with a sulfuric, and one other in there that one is a great one for just a light duty acid. Does a traditional good job of cleaning, but also is a very, very gentle acid as well. So which way do we want to go when we get to this acid cycle? We just talked with the Stronghold, talked about Strongholds, which is a traditional acid that would have to be followed when it's time to do your milking with a Sanitize cycle. We also have the option of an acid Sanitize, or we have an option of an acid wash, eliminating the alkaline. So we can take a look at a couple of the products that can be used in each of these areas as well. So we have our OxySan and OxyStrike acid sanitizers. These are both very similar and built on the same premise of a peracetic acid. So we can see they're using a 5% peracetic acid for the cleaning and sanitizing. We want to make sure we have a good clean surface ahead of time, and being used on our stainless and food contact surfaces here. So it's an acid rinse and sanitizer in one. Rapidly sanitizes at a range of temperatures. So this one can be used from your normal just tepid room temperature waters up to about that 110 degree range, and used in low concentrations for broad spectrum kill of gram-positive and gram-negative bacteria. This is these things all work for both the OxySan and the OxyStrike. Can be used in the sanitation and ultrafiltration, reverse osmosis membranes, and other similar types of systems, and can be used in sanitizing of animal, poultry premise, trucks, coops, and crates on the OxySan version. It does have several EPA registrations to be used in all kinds of industries. So this is one that will cross over and can be used in multiple areas. So as you can see with the OxySan, it can be used with conveyors, peelers, slicers, meats, poultry, seafoods, fruits, and vegetables. All have approvals and EPA registrations that will suffice for that. The OxyStrike is built on the same premise, only using a little punch of nitric acid. That is helping to bring the pH down, giving a little better shine and taking advantage of that nitric acid for helping to break the minerals up a little bit better. We found that one is working very, very well in bulk tanks, milk tanks, and such that way, giving a nice low pH, nice shine to the stainless. Very, very good on the cleaning side of that. Also, from a sales aspect in the dairy industry, the OxyStrike having that lower pH a lot of times can help keep the competition away. When the competition's coming in, taking a look at these types of things, they will a lot of times point at pH, while OxySan and several other acid sanitizers are designed to work at a higher pH. That oxy strike just allows people to see, hey, we've still got the pH factor at work there for the acidity side of it, and it's proving the strength that's there. So. And one of the other ones that we have and have had for a number of years is our AgriSand line. And we've, over the last couple of years, have improved this with AgriSand Plus. So this is a broad spectrum acid sanitizer. Again, this one works well. It's got a log 7 kill, low pH on this one as well. Works very, very well at removing water scale and mineral buildup. This is more of the traditional acid sanitizer that's been used in the industry for a number of years before the parasitic acids became popular. So this would be similar to your DeLaval Megasands, Ecolab mandates, and such that way. So again, showing the breakdown here, we can look at it for the acid sanitize, but the other option that we have is our one-step detergents. So with the one-step detergents, we're using an acid-based product instead of the alkaline to come in and do a full cleaning. So in this case, if someone's looking to save time or have some other options, here are a couple of options for that. We have the one-step CIP detergent. 2 proven germicides, 1 powerful product, concentrated non-foaming acid detergent formulated to clean the entire system in a single wash, placing standard acid and the chlorine alkaline detergent steps into one. So we're cleaning without foaming. Contains well-known acids to increase the potential for getting good premiums by doing a very strong good clean here, and using that combination of acids, surfactants, and emulsifiers to not only dissolve fats, proteins, and such that way, but also go after the mineral deposits too. So side effect of using this one as well, it's reducing the buildup of teat sealants. So if you are having issues with teat sealants building up in your system, this is definitely going to help to keep that at bay as well. And another option along with this one is you can not only get just the one-step detergent, we also have the one-step detergent available with the PAA, the parasitic acid in it as well. So you can have that little bit added benefit of using that parasitic acid in there to give you that extra shot of clean and extra advantage of sanitizing qualities that come with parasitic acid that way. And I want to just point out, we have a wide range of products, not only for milk house, but specialty cleanings, manual cleanings, T-tips, hoof care products, and everything as well. So if you're taking a look at agrichemusa.com, you can get in there and you'll find all of the information that we just hit on here, as well as much more on each of these products. You can get your tech data sheets, SDS sheets, and dealers can sign up for the back page, resources page, with additional information on trainings, additional links to more information for you to get more details on products, as well as be able to take a look at paying on your accounts and such as well. So lots of availability there through agrichemusa.com. Definitely want to get yourself signed up for the resources page on that. So, and that's what we have for our going over the basics of our CIP lines of products. Does anyone have any questions on the products or how they're used at this point, or want to get into more detail on the wash-ups themselves? Please feel free to throw some questions out.
Todd, this is Ginger. I have a question.
Yep.
So you just mentioned the one step with the parasitic acid being able to be used to help keep the Orbiseal and things out as well. Is there other ways to use parasitic acid into it for things like Spectromass, or how would you set up for that, whether it's with one step or maybe with an acid sanitizer?
For keeping them out, it will work to keep both Orbiseal and Spectromast and any of those that leave that greasy buildup that you can find, whether it's in cloths liners. A lot of times we see it built up in the in the receiver jars as well. That the acids in detergent acids that are used in this will work to help to keep that pulled out. So if you're using this at a traditional rate, the one steps tend to go in at a 1-to-1 ratio up to a 1-to-2 ratio. It is a little stronger use than a traditional detergent would be in that sense, where we're running traditional detergent at a 1-to-3. But if you're running that in that 1-to-1, 1-to-1.5, 1-to-2 range, it will work to keep that out. If you have a very heavy buildup of that to begin with, you can use our Agrisolve or teat sealant remover to run a special wash to get it out. You can use the one steps even in a stronger, essentially running it in a hot wash aspect of it. So I would run it in a 1-to-1 or even a little stronger than that, maybe a 1 to half a gallon that way to get a good solid removal aspect of it. But once you've gotten it out of the system, it does do a good job of keeping it out of the system.
Would it also work to do one of our other detergents and then follow up with peracetic acid sanitizer? Would that kind of essentially do the same? Or is one better than the other?
No, that will work as well. I think the one step has with the additional acids and tools that are in that, it does just a slight bit better job. But we've seen in a lot of cases we're using an OxySan or an OxyStrike as your acid sanitizer will also give those same results of keeping it out of the system.